5. Grabbed and subsequently wanders. What's that? Where did that other thing come from? Why is that object over there the way it is? When did all of this start? Who started it? What was that noise? Or that flash of light? How did I get here? What will happen tomorrow? Is that safe to eat? Where are my glasses? Many of our questions are practical. Some are philosophical. Whatever the topic, we want to know. Curiosity is deeply ingrained as an instinct in human nature. This trait, coupled with our intelligence and creativity, is the foundation of human success as a species. Our capacity for curiosity is limitless. Often, if we can't find the answer, we'll make up one just to move along. We're born with a capacity for curiosity, but we're not born with any limits to it. It seems we want to know everything. Arguably, the most famous scientist in history, Albert Einstein, once opined, "The important thing is not to stop questioning. Curiosity has its own reason for existing. One cannot help but be in awe when he contemplates the mysteries of eternity, of life, of the marvelous structure of reality. It is enough if one tries merely to comprehend a little of this mystery every day." My own sentiment is that to live well in the world, we must understand it. To understand the world, it behooves us to learn about nature and to develop the mental tools required to separate truth from fantasy. Science is an institutionalized, disciplined mechanism for doing this. Science is pro-social. It enables wise decisions about how to attain the future we wish for. Science is the exploration of all that is real, true, and possible. Anytime we wish to change the real world, much less understand it, we're required to think like a scientist. At the very least, it's advisable to learn about a thing or process before we roll up our sleeves and start tampering with it. Alternatively, knowing more about the natural world can give us a better sense of place and context within the wider universe, even if the vast bulk of the universe lies far beyond our grasp. This book is full of curiosities, and not many of them have practical importance, at least when it comes to providing food, safety, shelter, and prosperity. However, I believe that satisfying the very human need for experiencing wonder, of understanding one's place, origin, and surroundings, even the surrounding stars, are, in their own way, necessities of human flourishing. All right, that's the first reading. I'm going to paraphrase a little bit because I'm jumping into the middle of a topic here. The reading isn't exactly these words, but it'll blend into it here in a second. There are several dispositional characteristics consonant with a scientific view of the world. Critical thinking, certainly among them. I won't delve too deeply into them here. An extensive treatment warrants its own book, but here are some of my favorites, beginning with humility. Humility. You might be wrong. Other people might be right. There's a lot you don't know. It's always worth considering alternatives. Change your mind when warranted. Second, honesty. It's not a character flaw to admit an error or a mistake. It shows strength of character to discard your biases and assess new information impartially, even eagerly. Good evidence will stand on its own merits. Objectivity is an aspect of honesty. 3, there are 7 of these. Curiosity. There's a lot you don't know and little that you do. Always be exploring and learning. Think critically. We are prone to all sorts of biases and errors of thinking. Learn to spot your own fallacious thinking by studying the sorts of logical fallacies to which we're all prone, and then avoid them. Patience. It can take years to pry enough data out of observation and experiment to bolster or refute a hypothesis. Many natural things, such as growth of trees or the orbital period of Jupiter, can't be rushed. Democracy. Science is a marketplace of ideas. The best ideas win, not the loudest voices. Listen to what others have to say and judge an idea by its merit, not its messenger. Pick the best ideas and see how they fit together. On the other hand, appeal to popularity isn't relevant. Evidence trumps all else. And finally, irreverence. Nothing is sacred. No topic is off limits. Everything that is real or possible is open to questioning, scrutiny, refinement, and, in some cases, discovery. However, this does not imply that scientists should be disrespectful or merely contrarian. And I chose this slide to represent a person or several people who I think exhibited almost all of these characteristics in almost every circumstance. This is Marie Curie and her husband Pierre. They won the Nobel Prize. First married couple to do so. They're holding their daughter, Irene. Irene also won a Nobel Prize, as did her husband, the second couple to do so. And Marie Curie went on to win her second Nobel Prize. So there are 5 Nobel Prizes associated with the Curie family. And Marie Curie was always generous with her time and finances and her responsiveness to other curious minds and to people in need.
I wonder, is this on? You hearing the students?
Yeah.
Okay. I'm just wondering about some of the thoughts. It really bears a lot of discussion. You hear about honesty and humility, and it seems like those are often cudgels that are thrown at the other side in a scientific argument nowadays. You know, if you talk about the recent pandemic that we've had and the aspects of, well, people that are just saying that this COVID is something that has to be treated and the vaccines and so on are going to help us and so on, and people were throwing that as the honesty of that. Maybe they're just trying to sell their access to vaccines to people or something like, you know, there's a whole variety of different things, and each side can seem to take the high ground and say that science that doesn't agree with them, the science that doesn't agree with them is dishonest or not humble enough or not patient enough. I mean, that was the talk about the vaccines. They put the warp drive thing and they got the vaccines developed. And so in that case, there was this rush to completion on it.
Well, he didn't really have a choice in some circumstances, you know.
Right, yeah. So, I mean, I wanted to bring that up, that all these things you're talking about, people can throw those things at another side if they choose to about it.
Yeah, I know in politics, I gave a whole talk a few years ago about humility is a practiced character trait. You can practice it, you can learn it, you can develop it. And you can develop, it's like listening, right? Remember hearing people talk about intentional listening, careful listening. You know, I think humility is the same kind of thing. You can develop the skill for humility, and I think oftentimes that's left out when we try to instill behaviors and teach skills akin to critical thinking, which can also be learned. All right, I'm going to move on. Mathematically speaking, an asymptotic curve is a curve that gets ever closer to a particular value, but only reaches exactly the target value at infinity. Pretty much everywhere else along the curve, it's almost at the target value. This idea of an asymptotic approach to the ideal answer is one I find useful when talking about scientific progress. Scientific explanations asymptotically approach a perfect description of reality. In accord with the asymptotic representation of scientific progress, we are perfectly justified in claiming certainty as long as we're willing to live with a trifling small possibility of being surprised and mistaken. We can speak without equivocation unless we're pressed to admit to a challenger that our certainty is only vanishingly close to 100% absolute. However, we can be completely confident about some scientific claims, such as the fact that planets orbit the sun due to gravitational effects, even if we don't yet perfectly understand gravity. That table salt is composed of crystals formed by matched pairs of sodium and chlorine ions. We can be certain that clouds consist of water vapor, that human beings are animals, and so on. This representation shows my attempt to capture these ideas pictorially. In this depiction, whatever a person or a culture knows about nature represents a kind of path or trajectory toward an objective reality that exists independently of our ability to comprehend, represent, or possibly even communicate it. Reality itself never changes. It's a sort of brick wall of truth, wherein every brick is an inviolable law of nature or a natural fact. The best we can do, and one hopes we are trying our best, is to make inquiries about what is real and true, and to compare the mental models we create about reality to the evidence nature provides. That evidence may contradict our presumptions, or it may validate them. I suspect each of us can recall a time in our lives when we believed unrealistic and inaccurate things about nature. All right. Now, those readings were essentially from the introduction and a little bit of chapter 1. Chapter 1 is what is science? The introduction is why do we need another science book, essentially. All right, this is from chapter 2, which deals with stellar nucleosynthesis largely, and I'm sure you're all familiar with how that works, so I'm not going to go into that in detail. But the book does. But this is the sort of the introductory spiel for the chapter on the way stars work. The sun looks like a golden yellow orb. Oh, by the way, this section is titled The Alchemists. And so often seems to cast a golden light. For much of human history, people have believed the sun to be eternal, perfect, and a primal source of life. Many cultures have imbued the sun not just with the properties of life-giving heat and light, but have embellished their notion of it to include intentionality and sentience. They made it into a god, always keen to discover or justify links between the heavens and the earth. Some leading thinkers in pre-modern times looked for some evidence of godly sunness on earth. In medieval times, some natural philosophers perceived a connection between the yellow orb of the sun and that most precious and eternal of metals, gold. Since gold is also yellow, and since it does not fade or tarnish, they hypothesized some link between gold and the sun and perfection itself. These people, better known as alchemists, sought some means to turn imperfect lead, which was almost exactly like gold. It had a great density, it was metallic and soft and malleable, to turn it into gold. Some also thought they could use the silvery liquid metal, very dense, mercury, as an object of transmutation instead. In the thinking of many alchemists, the only significant property required to make lead into gold was a bright yellow color. Seeking this color, they would frequently try combining lead with yellow sulfur or golden urine to coax the gray lead into becoming lustrous gold. Alchemists combined many different technical disciplines in their pursuits. They noted that the sun was only one of 7 special astronomical bodies visible in the sky. The others were the moon, the planets, Mercury, Venus, Mars, Saturn, and Jupiter. The Earth wasn't accounted among this number because the Earth seemed much larger and was perceived as the center around which the heavenly bodies held court. The ancients reasoned that if the sun was life-giving and eternal, surely the other 6 prominent celestial bodies were also important. Maybe they were associated with different things like love, war, wisdom, and whatnot. This created a conceptual link between the pursuits of astrology and alchemy. As an aside, note that the week has 7 days. This convention goes back at least to the ancient Babylonians and then made its way into other cultures. This is plausibly related to the religious and cultural prominence of the 7 visible celestial objects in ancient times. The number 7 itself shows up in various contexts as a supposedly perfect or magical number. For example, the ancients supposed there were 7 seas, 7 continents, and 7 wonders of the world. In Christianity, there are supposedly 7 deadly sins and 7 angels of the apocalypse. The mystical practices of numerology within which the number 7 is important supposes a link between number patterns and the occult, fortune-telling, prosperity magic, etc. Numerology is also intertwined with alchemical and astrological practices. All of these ancient endeavors, astrology, alchemy, and numerology, were ultimately unsuccessful as methods to understand the world, make predictions, or change the future. But each gave rise to a science that has been helpful in these regards. Astrology birthed astronomy, alchemy birthed chemistry, and numerology laid the foundations of geometry and mathematics. The occult notions that accompanied the earlier arcane practices have been discarded by the sciences that inherited some of their methods, because there's never been any evidence of the wished-for magic. All of the modern descendant sciences are now firmly associated with natural philosophy and the search for evidence-based descriptions of how nature works. In Christendom, at least, alchemists were viewed as dangerous. Not only were they supposedly doing magic of an occult sort, but their reputed ability to create gold would potentially destabilize sovereign governments and trade. Consequently, alchemy was a capital offense in many cultures. Many alchemists, understandably, kept their activities secret. They worked at night with noisome chemicals. Unfortunately, the stink of these chemicals sometimes tattled on them and their illegal pursuits, as a miasma followed them around town, clinging to their garments and hair. It took a lot of courage and no small amount of hygiene to survive as an alchemist. If they needed to communicate with one another, they did so by means of secret codes. Some scholars think that the 8th century Persian alchemist Jabir ibn Hayyan had such an infamous code that his name became synonymous with untranslatable nonsense, gibberish. For a while, the practices of occultism and of natural science overlapped. As late as the mid-17th century, for example, the prominent natural philosopher Isaac Newton, perhaps you've heard of him, spent a great deal of time pursuing alchemy and numerology. By then, thankfully, such occult undertakings were not a capital offense in England. However, it's telling that Newton thought these occult adventures were valid means of uncovering truth about the cosmos. About a third of his extant writings deal with these arcane topics. Let's return to the central question of alchemy. Can other elements be turned into gold? Just how might gold come into being? These are excellent questions. Eventually, as this chapter progresses, I'll tell you the answers. For now, I'll note that the alchemists' attempts were doomed to fail for no reason they could discern with their available technology. Making gold wasn't the end goal of most alchemists, though. Nice as a pile of gold would be. You see, their ultimate objective was to redeploy the device or substance that would do the magic of turning lead into gold for another purpose altogether. Their reasoning went as follows. The alchemist's hoped for final concoction or mechanism was expected to turn some imperfect material or materials into the most perfect element, gold. Gold will never tarnish, never fade, and it will be like a bit of the life-giving sun brought down to earth. The same process for turning boring lead into magnificent gold may, then, be expected to turn imperfect, mortal humans into immortal, perfect beings. The alchemist's material, once it was discovered, was expected to be able to be ground into a paste or powder that could then be added to liquid and ingested. This magical substance would then, the reasoning goes, be an elixir of immortality. It's a simple and alluring idea. This fanciful material was dubbed the Philosopher's Stone. So that's the introduction to a chapter about stellar nucleosynthesis. I'm sorry? Yeah. All right, so each chapter in the book, except for the last one, for reasons that will become clear if you read it, each chapter in the book, I end with a section I call Reflections. And in the Reflections, I talk about some historical or mythological or philosophical context in which the previous chapter's scientific explication might be relevant or informative. So this is the part of the Reflections section for the chapter on stellar nucleosynthesis, the lives and deaths of stars. Long ago and far away, in a sandy desert located in a desolate part of the world, there sat a meteorite, a fragment of a space rock that plunged through the Earth's atmosphere, ablating off layer after layer of itself in response to the searing heat of atmospheric friction. This meteorite, like many, was metallic. By the way, can you see the person in this picture? This is a giant meteorite. The meteorite, like many, was metallic, comprising a mass of nickel and iron. We now know that these elements were formed in the core of some massive star that exploded. Why am I suddenly popular this morning? Oh, thank you. Some massive star that exploded before our solar system was born. The people who found it, though, thousands of years ago, knew nothing of atmospheric friction and heating. They weren't stupid by any means, but they had not yet had the benefit of generations of systemic scientific experimentation or the use of clever inventions such as the telescope or the spectrograph. They knew nothing about the atomic structure and difference between iron and nickel. Only in this way were they ignorant. They were ignorant of the fact that iron is the poison pill for stars. Previously in the chapter I talked about, once a star synthesizes iron at its core, it's done making energy. It's no longer a star emitting energy and light. And so iron is a poison pill that causes stars to die. Nobody knew much of anything accurate about the elements or atoms or stars. Nobody could have imagined that iron's presence in distant, massive stellar cores that were millions of degrees hot and crushingly dense, signaled the end of the last possible process of energy-liberating fusion just before a supernova blast. They were ignorant that the supernova blast of the particular star which birthed that particular meteorite likely provided much of the raw material for Earth itself, as well as the carbon, iron, nitrogen, and other elements within their bodies. They were ignorant of these facts and many others. Still, they were impressed with the blackened and metallic meteorite. Iron meteorites were, after all, useful. Unlike other rocks they used to make implements, these did not crack and cleave when heated or struck. Instead, the metal rocks could be hammered and shaped and sharpened into rare and wonderful tools. A meteorite, large, black, heavy, and sitting alone in the desert, must have seemed like a rare and generous gift from the gods. And this is a picture of where the meteorite was found, and it still rests there because it's, 60 tons. Long before humanity learned how to collect, smelt, and form naturally occurring terrestrial iron, likely from bog iron, and I have a footnote explaining bog iron, accumulated around riverbanks, iron meteorites were the only useful source of this incredibly durable and shapeable metal. Archaeologists suspect that the first iron implements were pounded out of iron meteorites. For example, a dagger found in King Tutankhamun's sarcophagus, whoops, where's that? Did I skip that? Yeah. A dagger found in King Tutankhamun's sarcophagus was made from meteoritic iron before he was buried 3,500 years ago. The occasional meteorite, which is much easier to locate in a desert than in forests or river bogs, was an immensely valuable find. They must have seemed like propitious gifts, put there just for people to find and to give to their kings. Some ancient peoples, including the Egyptians, knew that meteorites came from the sky. That, combined with their rarity, their stark incongruity with local rocks, and their usefulness, must have made them seem miraculous. Miracles are worthy of worship, and these iron stones were no exception. Instances of stone worship are relatively common within many cultures in ancient times, and meteorites would have been particularly good candidates. Not all meteorites were nearly pure iron or nickel, though. Most are stony meteorites, though they may also contain a great deal of iron compared to terrestrial rocks. A smaller number of meteorites are brittle and carbon-rich, called carbonaceous chrondites. These are believed to be the most primitive of the known meteorite types, closest to the chemical composition of the raw pre-solar nebula, having not been subjected to metamorphic heating or pressures or differentiation. There are other rocks that can be mistaken for meteorites. The ejecta and debris blasted out of Earth when a meteorite hits can melt into slag and form a kind of volcanic glass. In all cases, meteorites and their debris are rare. Even casual observation by people lacking scientific knowledge leads to the conclusion that these rocks are special. For many people throughout time, it was entirely reasonable that rare and special objects were worthy of veneration. Perhaps these stones wielded magical powers or were otherwise tied to the realm of the gods. This connection must have been even more obvious if somehow it became known or even suspected that they originated from among the stars. In what is now the Arabian Peninsula, a temple was built, perhaps more than 2,000 years ago. This temple was, according to ancient accounts, filled with revered objects, with the idols and talismans of many gods. It occupied the site that had been deemed sacred since time immemorial. Bedouin tribes, the Nabateans, made annual pilgrimages to this site before the rise of Islam or Christianity. There they worshipped their gods Al-Rahman and Hubal. Within this holy shrine, or perhaps set within one of its walls, was placed a black stone, an object of devotion in of itself. Quite possibly, although not known for certain, this stone originated as a meteorite. It might also be a bit of glass created from a meteorite impact, or even a stone of volcanic origin, meteorite imposters. Without a doubt, though, it was a peculiar-looking stone, quite out of place in the sandy desert. The temple had, and its black stone was fought over by contesting tribes and factions over the centuries. Over time and through many periods of conflict, destruction, and rebuilding, and the migration of peoples in the region, the temple, called the Kaaba, meaning cube, had been rebuilt. The black stone within it was moved out and back as control of the site and its cache of idols shifted. Once, after a military assault on the Kaaba, the black stone was shattered into at least 11 pieces. Through it all, people continued to worship this stone, this possible meteorite. Religious ritual associated with this site persisted through the centuries, even until the time Islam's founder, Muhammad, said to be God's final prophet, became involved in the story, about 600 current era. After some travels, negotiations, and warfare, Muhammad and his followers captured the site of the Kaaba shrine. He had the Kaaba cleared of idols, purportedly 360 of them, but left the black stone, the rock of purported heavenly origin, in place. According to Muhammad's religious mythology, the black stone was sent by God down to Adam and Eve, the first humans, to serve as an altar for their worship. To this day, the suspected meteorite resides within the Kaaba, set within a silver frame, wires that were used to put the pieces back together. It's several black fragments held together by silver wire. Oh, I guess I do write that. Every year, a great pilgrimage, a continuation of ancient pagan rites, sees thousands of people gathering around the Kaaba and worshiping Allah. Muslims from all over the world learn to face this temple 5 times a day during ritual prayer. The Kaaba temple and the black stone it contains is the holiest site in Islam. According to Islamic tradition, the black stone fell from paradise and was found by Adam and Eve and used by them as an altar, or perhaps it fell from heaven as an indication of where God wanted them to build an altar. Another conflicting tradition says the stone was carried from heaven by an angel who gave it to Abraham as a cornerstone of the original Kaaba. The site of the Kaaba, according to Islamic tradition, is also where Abraham and his eldest son, Ishmael, and it was Abraham who instructed the Kaaba to be built. Abraham and Ishmael built it. The black stone within the ancient temple Kaaba is in the holy city of Mecca. Every Muslim is exhorted to visit Mecca at least once in their life, to kiss the black stone. If they cannot kiss it, they're to join the crowd circling the Kaaba and pointing a hand in the direction of the stone. This is a sacred bit of star stuff. But then, aren't we all? Long ago, and throughout the world, people deified the stars and planets. This fact is well known. Less well known is that cultures around the world, including Britain, China, Japan, Egypt, Rome, and Native American cultures in the Americas, venerated meteorites. They were perceived as holy relics hurled to earth by sky gods. Pre-scientific cultures could do little more than be amazed and impressed by the cosmos and daunted by the mysteries of nature. They were not yet possessed of the necessary ideas or tools to discover the cause of most natural phenomena, from the mundane to the exceptional. They venerated the power of nature, but did not understand it much at all, beyond learning about natural rhythms of seasons and seasonal effects, plant and animal distribution, and eventually agricultural practices. Our ancient forebears, confronted with inscrutable mysteries, made up stories about the stars, about origins, about the gods and spirits whose whims were tied to propitious or deadly states of affairs, and about many other things. They made up complex stories about the stars and planets and gods, with their various grudges and dispositions, and how these things related to their lives. They invented horoscopes and astrology to link the chaotic fates of persons with the regular motions of planets, without any demonstrable success. They did these things not because of foolish whimsy, but because they were compelled by a laudable human drive relevant to individuals to this day, the drive to know and understand and explain. Without some sort of story and some sort of interpretation, the mysteries of nature might well be overwhelming and numbing. Few people, perhaps none, were willing to accept that nature ignored human needs and well-being. Surely, they conceivably reasoned, humans are a special species compared to all other living things on Earth. The special capacity of people to reason, to feel emotion, to create art and communicate, to imagine the future and recall the past, to set stories for the future, to set stores for the future and ponder their own mortality, set people far apart from other living things. They could not help but feel special. Being special, it must have seemed that the wider world was somehow made for them. When the circumstances of the world turned inhospitable or deadly, surely it was because of something they did wrong, something that angered higher powers, or perhaps the higher powers were simply being capricious or even callously malevolent. In that case, sacrifice, worship, and other ritual attempts to call attention to the cavorting and negligent gods to themselves and include them induce them to be benevolent or to intercede and forestall the malice of the gods themselves. Such attempts seemed prudent. They did the best they could, as all of us do now. Long ago, the people of the world were not much different from us. They loved their children, feared pain and suffering, wanted the best for their friends, and strove to understand how to make their way successfully through a complicated world. However, lacking our accumulated knowledge of science and derivative technology, including medicine, their only recourses were wishful thinking and heartfelt supplications directed at imagined superpowers who consciously controlled nature and its fates. Rocks that fell from the realms of the gods surely meant something. Cultures around the world all came to that same conclusion. What we know today is that the connection between ourselves and the stars above is far more intimate, yet more convoluted than any ancient tall tales could have foretold. No supposedly divine-inspired tale of the world's creation talks about our real link to the stars. No religious text has ever revealed the astonishing alchemy of stars, wherein new chemical elements are forged from progenitor ones, much less the path of those elements as they travel from the stars to us. No text of celestial wisdom tells us that stars are finite, mobile, and mortal things, which scatter their dying dust into a wider galaxy. The true connections between the material of our planet, including all of its living things, including every human being, is never mentioned by any prophet speaking on behalf of any god. The stars were provably not set within the firmament as signs, a fact demonstrated by the truth that more than 99.99999999999999994. That's 15 nines. Percent of them, of all the stars in the universe, exist beyond the perception of our eyes. They are irrelevant to our galaxy, much less to the goings-on of our solar system, in which our planet lives. Even the closest stars are irrelevant in that context, notwithstanding plausibly a nearby supernova every few billion years. Surely, divinely dispensed truth from an infinitely knowledgeable, transcendent being could have included a sentence or two about the fact that stars are temporary and dynamic things. Stars move, they change color and temperature and size. They're born and they die. They create heavy elements. One wonders why the gods forgot to mention that the stars are other suns. They are vastly more distant than the 5 planets we see in the night sky, or that nearly every star has its own retinue of planets. Is it a mere oversight that none of the thousands of putative gods worshipped by humanity talked about the clouds of organic molecules orbiting and percolating in the heat of distant suns, and how the matter in our own bodies derive from dead stars? Missing entirely are any ancient revelations about the true nature of comets, meteors, stars, planets, auroras, supernovas, rainbows, non-visible light radiation. There are no dispensed insights concerning the universal law of gravitation or the specification of celestial distance and timescales. The holy books only contain information concerning what people living in pre-scientific age at low latitudes could see with their eyes. It seems necessary to me that wisdom must be preceded by knowledge, which must be preceded by accurate information. Perhaps the wisdom of the gods is a special sort, able to blithely disregard the knowledge we have acquired about nature, whether illuminating our status within a larger celestial domain or explaining the mysteries of our cosmic genesis. I doubt it, though, profoundly and justifiably so. Facts and reality, real things like stars and iron meteorites exist, and they have amazing truths to tell. Only from these truths can we extrapolate wisdom regarding what is possible and how to best understand nature and effect change. Spells and prayers offered to meteorites will never be a good replacement, and they never really were. From my part, I believe that after tens of thousands of years of finding reasons to worship rocks, we can all safely and wisely move on.
Scott, you mentioned that the terminal point of a sun is iron, but we have elements that are heavier. Could you briefly comment about how we get big, heavy things?
Yeah, the supernovas create such a confluence of energy and particles that it generates elements heavier than iron. I want to show you the table of contents. The book talks about the stellar life cycle. That's what I was just going into. Has a chapter about measurement and dating, not that kind of dating. Has a chapter about cosmology, and then wraps up with a talk about the idea of multiple universes. And here is the table of contents. All right, that's all I had to read for today. We can take 10, 15 minutes for questions and discussion.
Yeah, we have, here, John, I'll give you.
Yeah, with the Webb telescope, there's been a lot of new information out there, and of course, starting to question whether the Big Bang is really true.
No, we're not.
We're not?
No.
Okay. Some people are.
Yeah, there's been some sensationalist headlines about some of the, especially the early non-peer-reviewed scientific hypotheses put forward to explain some of the Webb data. And some of the headlines in the popular press have been highly exaggerated and rabble-rousing, you know, like the Big Bang may not have there's like one scientist somewhere, a professional, right? I mean, it takes all sorts of ideas, and the good ones rise to the top after they're reviewed and analyzed. There's some scientist, I don't remember his name or his institution, who said, well, maybe that we need to rethink the old, what's called a steady state theory of the universe. But, you know, that's one voice in a wilderness maybe that has merit, but most people who've looked at his reasoning and how he's looked at the data don't think he's onto anything. So, yeah, you may find a headline or several headlines about that, but the overwhelming consensus is that the Webb telescope is actually validating the Big Bang. We see some of the galaxies it's finding are bigger than expected for that epoch of cosmic history, but the redshift that they have is consonant with a expanding universe that started from hot nuclear ball of stuff, and I go into a lot of that in the book.
Okay, that kind of falls in just a general comment that everyone should be aware of. False experts, and not all opinions are equivalent.
Right, yeah.
So there's a lot, just because they got a PhD after their name, you know, it could be in English lit, that's one.
Right. I don't have a PhD, and I don't put forward, other than maybe one, what I would consider original idea in my books.
But you do footnote it, so we could get, I hope,
Right.
that we can get to the
Right.
original source.
Yeah, I view myself as an educator and communicator. I'm not a practitioner. I don't go out and do research. All right.
Any other questions or thoughts? It's amazing topic.
Well, we have a minute. I've got one final thing I could read.
Here, hold on.
Can you talk about your thoughts on the multiverse?
Yeah, so if you look at the chapter on the multiverse, turn to page 589 or something, I don't know. There's chapter 6, Universes Beyond Measure, page 385. There are a few types of multiverse I talk about. Statistical multiverse, the quantum multiverse, the inflationary multiverse, the time travel multiverse, the anthropic multiverse, and then an original, I believe, idea of mine I call the human multiverse. And I don't think we have time left today to talk about the distinction between the different kinds of multiverse, other than for me to highlight that different lines of reasoning in science, and I talk about the philosophy of the very notion of a multiverse, like what's it mean to posit that there are universes that we cannot even in principle ever measure, ever reach, ever observe in any way, shape, or form. Is that even science? And I talk a bit about the philosophy of that. But what each of these notions of a universe derives from is a reasonable extrapolation of the laws of nature that we have codified as our laws of science. So if you take some of the things we know, like, let me give you one brief example. Where we are sitting in the universe, it looks like every galaxy is rushing away from us. Do we smell bad? Right? What have we done to offend the rest of the universe? Well, when you look at the situation more carefully, you find that space is expanding. Things aren't moving through space. The space in which galaxies are embedded is increasing its scale, its measuring scale over time. It's like raisins in a loaf of bread that's being baked. The raisins don't change shape or size, but they become further apart as the loaf of bread expands. So that's one kind of multiverse that you can picture yourself as a special raisin, and you look out and you see a cosmic horizon that's as distant as the speed of light over the age of the universe can account for. But what if you were on a galaxy that was just at the edge of what we can observe? You know, imagine a disk. If we're at the center of the disk, what if you're on a galaxy that's towards the edge of the disk? Do you look off in one direction of the sky and see darkness because the universe stops at your galaxy? No, plausibly, no. What you likely see is a sky littered with galaxies just like we do, and all of those galaxies, some are near, some are far, all of them are receding. Well, the more distant ones are receding. Close-in gravitational effects can make close-in galaxies not recede from your point of view. So the idea of a statistical multiverse, the first one I talk about, has to do with the idea that maybe an literally infinite amount of stuff was generated during the Big Bang, but we can only see as far as our cosmic horizon. And if you go to the edge of our cosmic horizon, they've got a cosmic horizon. And if you go to the edge of their cosmic horizon, they've got a cosmic horizon. Why would you ever stop? Maybe there's a reason to stop, maybe there isn't. One of the speculations is maybe there's no reason to ever stop. And so, given an infinite amount of material and an infinite number of stars lying beyond our horizon, matter can only rearrange itself according to factorial combinatoric principles. You know, you take 10 things arranged 5 different ways, and there's a finite number of ways you can do that. Well, that's called the statistical multiverse. Somewhere out there, quintillions of light years away, matter, statistically speaking, will have arranged itself into patterns very much, if not identical, to how we are. So that's the statistical multiverse. And then there's quantum, inflationary multiverse, time travel multiverse, anthropic multiverse, and a human multiverse. The human multiverse idea is everything you know, everything you've learned, everything you think and believe, everything you perceive, everything you wish for, it's not out there, it's in here. And every time you meet another human being, you're meeting another model of the universe. So every human being is his or her own copy of a worldview, of a context within about where they exist in the universe, a perception about what's real and true. So every human being is a kind of universe that you have a splendid opportunity to interact with, learn from, and share with. And that leads to my last reading. Looking around, and especially up, you can be overwhelmed by the vastness of it all. The triviality of a single galaxy, the inconsequentiality of a single star, the brevity and isolation of a single life, the banality of a day. Think of being in a dark and barren desert, bereft of life and sound, guided only by the wan light of distant stars. That's what it's likely like nearly everywhere in the universe. You might feel alone, isolated, afraid, and insignificant. Now think about having a friend nearby, or a loved one, or a welcoming stranger. You might feel compelled to reach out and to clasp hands, to thrill in the warmth of companionship of another lonely being. You might raise your voices together, exultant about a shared experience, at being able to count stars and heartbeats and footsteps. You might fill the night with song. You aren't alone, neither in your wonderment, nor in your striving, not even in your wandering. Countless small universes, similar enough to be comforting, but different enough to be beguiling, wander alongside you, each person a world parallel to your own. What will you do with your universe? I hope you fill it, as you're able, with curiosity, knowledge, joy, and above all, love. All right.
Thanks, Scott. If you don't get emails from me and would like to, you can sign up over here. I just try to send out 2 or 3 a month, just reminding you of the time we're meeting and the topic and so on. So if you'd like to get that, you can put your name over here on this page, and I'll add you to the email list, and we send out invitations each time. 2 weeks from now, Scott will be talking about your second book, right?
Right. This first book covers the content you see there. The second book is about modern physics, starting with relativity theory, which can arguably be called the last part of classical physics. So relativity theory, particle physics, quantum mechanics, the Higgs particle, ideas of unified theories and whatnot. So that's what the second book's about.
And I think basically your intent and our intent in Science Sunday is to try to make some of these topics that may seem very arcane, very complex.
Or inaccessible, yeah.
To try to make them accessible and understandable to people with intelligence and curiosity.
Yep.
The topic today in the service that's going to be starting in about 12 minutes is about radical curiosity as well too. So I think it ties in a lot with what you talked about, especially in the first part of your talk today, too. So feel free to go over to the other side of the building for a 10:30 or 11:30 start, I'm sorry, at DUUC. So
All right.
thanks so much for coming. It was a nice turnout. We're looking to build a community of people wanting to talk about science and interact with each other, question and discuss topics. So thanks so much for coming, and keep on building this up.
I ask that if you buy the book, and if you then proceed to read it, please leave a review, an honest review. If it's 1 star, if it's 5 stars, if it's 2 stars. Feedback is something I thrive on, every author thrives on. And writing a book is a long process, as a couple of authors in the audience can attest to. Yeah, the best way to find it on Amazon, because it hasn't sold well yet, you know, I don't have a publisher, I'm self-published, I don't have a press agent or anything. The best way to find it is to search for my name on the Amazon search box, Scott Thompson, and then you'll find the books, and you'll recognize it from the cover. But it's called A Wanderer's Journey Through a Wonderful Cosmos, Quest Volume 1, but just search for my name, that's the best. I know you wrote a book, Carl, you wrote a book, Joanne, you wrote a book. I don't know if we have other authors, but it's almost always, I think, a labor of love. Rarely is it, you know, when you're in a circumstance as an author where you can make a living at it and you do it just to make dollars. So
Joanne wrote a plethora of books.
she has. She's written a series, fantasy series.
Fantasy series, right. And Carl wrote about Nash Dinosaur Land, his home growing up in Massachusetts, and his father selling and collecting fossil tracks. And Karen, I'm not sure what.
It's a multiverse love story.
Multiverse love
It's
story.
love across parallel universes. It's called The Memories Between Us.
That's fantastic.
All right. So thanks so much for coming to Science Sunday, 2 weeks from today here at 10:15. If you want to get on the email list and get any reminders